At this point, it says use graphing technology to solve. We are going to learn algebraic solutions for these as well. But at this point, it says using graphing technology. What we're going to do, like we did before, you can put one equation into y1, another equation into y2. I guess your other option is to make everything equal to 0 and find your x-intercepts, but I like this better. Type both of those equations in. So in y1, clear out anything else you might have. So in y1, we have the square root of 3x plus 2. And in y2, we've got negative 6 plus x. So when we look at those two graphs, I'm just going to stop them temporarily and go zoom 6 to a standard window. So your graph should look like this if you're on the standard window like me. And will they intersect on our screen? Oh, just barely off. So we go to our window and say, it looks like I'm going to need a little bit more. So on my x max, maybe I'll go to 20. That should be more than enough to see those two graphs intersect. And it is. The solution to that problem is where they cross. We can find that by going second, calculate. Number 5, the intersection. Enter on the first curve, enter on the second curve, enter to guess. And this is why I like doing the y1 and the y2 better than the x-intercept method. Because if you're finding the x-intercept, you had to go to the left and to the right. I find it takes a little bit more time than just going curve 1, curve 2, enter, enter, enter. And we were trying to solve for x, and so x is going to be 12.2. And that's to the nearest tenth. That's how we would do this solving with technology. Later on, we're going to solve these. Some of these questions might be on a non-calculator part of the exam. If this question was on the non-calculator part of the exam, this is what you would have to do. You would want to get rid of your square root. How do you get rid of square root signs? You square it. So the first thing you would do is square both sides, and you would get on this side 3x plus 2, because squaring would get rid of the square root. On this side, you would get this whole thing squared, and when you square negative 6 plus x, you're going to have to FOIL. And when you FOIL that out, you're going to get 36 minus 12x plus x squared. So the number one mistake what students make when they square that side is they just write 36 plus x squared. They just square the negative 6 and they square the x. But you're squaring the whole side. You're going to have to FOIL and multiply it out. What kind of equation is this? Quadratic. How do you solve quadratic equations? You make one side equal to 0. So I have minus and minus the 2. So I get x squared minus 15x plus 34. One thing I already know about my solution, because I solved it. What did we get as our answer? 12.2 blah, 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 blah. It was a long decimal. That means that this is not going to be able to factor. We could try things that makes 34, 17 and 2 come so close, but they'd either both have to be negative or both positive, and that will never get you 15. So it looks like it should be able to factor, but it doesn't. I know from the answer above that it's going to be something that isn't nice, so I'm going to use my quadratic formula to solve for this. Negative b plus or minus b squared, 15 squared is 225, minus 4 times a times c, all divided by 2 times a, and a is 1. So I get 15 plus or minus the square root of 4 times 34 is 120, 136. 225 minus 136, 89. So we get the square root of 89 over 2. Now, when we type this into our calculator to figure out what these answers are, 15 plus the square root of 89 divided by 2, we get our 12.2. But in this formula, we also have a subtraction. So when I do 15 minus the square root of 89, all divided by 2, it appears that I get another answer of 2.78. Why did my calculator only show me the one answer? I know from my calculator that this one was right. Why do I get this other answer? Well, one of the things when we do these algebraically that we're going to learn is whenever you square both sides, which we did earlier, we're going to have to check our original answers to see if they work. And when I plug in 12.2, it's going to work. But I'm going to just show you why when you plug in 2.78, it doesn't work. The square root of a number is always positive. So when I plug in 2.78 here, I'm going to get 3 times 2.78 plus 2. I'm going to get a number that's close to 11. Square root of 11 is going to be 3 point something. But when I put in 2.78 into this side for x, negative 6 plus 2.78 is going to be negative 3 point something. The square root of a number is always positive. So when we go to check this, this one is called an extraneous root. Yes? No. I did this, that's an approximation sign because I rounded. If you do a normal equals sign, you won't get docked marks. In the International Baccalaureate program, they do dock off marks for not using the approximation sign, but not here. Okay, so the question for this one is, oh, did I give you number 9 for the last one? Yeah. Number 9 was for this one. Sorry. Number 10 and 12 were for the last one.